Okay, guys, so what I'm hoping to do here is go through the at least a portion of the questions that go along with the case study in case I went too fast in class and you didn't catch all of it. All right? So number one, we're going to skip over because number one, we have that entire video on thermoregulation, body temperature homeostasis. You can check that out. That's that video covers really number 1 and number 6 all the way through. So what I'm going to start with was number 2, which asks, what will his complexion look like? So we've got this guy wandering through the desert. He's very hot, and he's trying to cool his body down. What we're hoping to see here is the fact that he is going to be red in the face. Okay, he's going to be red because remember he's currently going through vasodilation to let out heat. So remember, vasodilation is when we open up the blood vessels, more blood flows into the skin. And the real reason is to get rid of heat, so it can actually leave through the surface of the skin. But at the same time, that's going to bring more blood to the surface of the skin, and it's going to make the person's skin look red. Most of you guys have seen that at some point. When a individual's hot, their face will be kind of bright red. That's what's going on. In terms of number 3, really what we're focusing on is what else is the skin, the integument, what does the skin do to aid Mike as he's stuck in the desert here. So the biggest ideas are these ideas of protection over here. So it serves as a barrier. Remember, it makes melanin, which is the pigment that protects us from UV rays. Abrasion is just like a physical scraping, things like that. So it would be a barrier to help protect that way. Probably the most important in this particular case would be the dehydration, guys. Dehydration. Remember, the skin serves as a waterproofer, so it holds in moisture. Even though we sacrifice moisture to cool the body down, we don't normally throw water away. So we don't want water randomly evaporating from the body. We want to hold in as much as possible. Some of you guys may have also put things down like production of vitamin D, things along those lines. There are some other things, but these are the primary ones I was trying to get at with this particular question. Okay, so number 4, we're talking about heat exhaustion. All right, so he's been in the desert. As he's going through the day, he's becoming more tired. He's starting to see muscle cramps. He's getting fatigue. He's getting dizziness. Just general exhaustion. Okay. Now, most of that is going to come from one of 2 causes. Okay. One of the causes has to do with ions. All right, so in terms of ions, remember ions is another way of saying the salts, the inorganic salts or electrolytes that we sweat out of the body. So if we're sweating out all the sodium and the potassium, things like that, well, they're needed for your muscles and nerves to function, guys. So muscles and nerves don't work well without the proper balance of of those ions. So right away, you could see weakness in the muscles. Okay, you could see a slower response time because the signals aren't moving through the nerves as fast. You can see all sorts of effects upon the muscles, including cramping caused by that. Right? The other big idea that we need to talk about is blood pressure. So in this scenario, his blood pressure has dropped dramatically. Okay, his blood pressure has probably dropped dramatically, and there's 2 reasons for it, guys. All right, so the first good reason both reasons have to do with him staying cool. So he's doing 2 things to stay cool. He's sweating and he's vasodilating. Okay, so the vasodilation and the sweating, both of those things drop blood pressure. So let's look at how. All right, so the first idea I want to tackle here is the idea of sweating. So sweating, most people don't think of this, but sweating uses water from your blood. That's where most of that water is going to come from, is from your blood. So all the sweat that comes out of your body essentially decreases the blood volume. All right, and if you make the blood volume go down, the blood pressure has to go down as well. Okay, it's a matter of physics. So if you drop the blood volume, then the blood pressure drops. Okay, the only way your body can compensate for that would be to actually vasoconstrict, close the blood vessels, and we can't do that right now. We're actually doing the exact opposite. So in this case, you have sweating and the blood volume is going down. Which means your blood pressure is dropping, and then at the same time you're going to vasodilate. So when the blood vessels vasodilate, they're enlarging in order to let heat out of the body, but anytime they expand, if you've got a blood vessel and you've got a blood vessel that's normally this size in diameter, goes muscles around there and the blood's flowing through it, if all of a sudden that expands out to much larger, okay, this extra space results in a drop in pressure. All right, so the two things combined result in your blood pressure dropping. You have sweating, okay, in order to release heat, and vasodilation in order to release heat. So it's not intended, guys. When you're hot, you're not trying to lower your blood pressure. In fact, his body will try and compensate. His heart will beat faster to try and keep this from happening. He'll do just about anything to keep this from happening, but he has to keep sweating to stay cool, and he has to keep the blood vessels dilated in order to stay cool. Otherwise, he'll overheat and die from that. The last bit that I want to mention here, guys, is remember that the question actually talks about confusion and lightheadedness and dizziness. And a lot of that comes from the idea of blood getting to the brain. So if we kind of look, and we got our heart sitting right here in the middle. Here's the beautiful heart, and here's your head with your brain sitting right in the middle. You have to be able to pump the blood all the way up there. Okay, so most of your body, when the blood comes out of the heart, it just kind of goes down to your arms, it goes down to your legs, goes wherever, okay? But this spot going up to the brain, you have to actually fight gravity. So it's the hardest spot for your blood to actually, when your blood pressure is low, to get it there, okay? So if there's not enough blood getting to the brain, then you get the brain starving for oxygen, you become lightheaded, dizzy, the same symptoms you would see if somebody was actually suffocating, if they weren't getting enough, if they weren't able to get enough oxygen into the body, or if somebody was being choked and somebody was squeezing the blood vessels and not letting enough blood get up to the brain, you'd see the exact same symptoms from there. All right. So all in all, heat exhaustion. Okay, we got the confusion, we got the lightheadedness, dizziness, cramping, fatigue, all that happening, and really you got a couple big causes. The ions, okay, are being sweated out of the body, not replaced, which affects the muscles and nerves. You have the blood pressure dropping because of all the sweating to stay cool and the vasodilation. And because of that, it's really hard to get blood from this heart up to the brain. So this brain right here needs the blood, and it has a really high blood supply and blood demand. And with low blood pressure, you just don't get enough to it. Okay, so on to number 5. So with number 5, there were a couple things you needed to know. All right, the first fact is ADH. So ADH is a hormone. Okay, so ADH is a hormone, and what it does is it actually helps the kidneys conserve water. It helps you make less urine. So this is what you're always releasing a little bit of this to help conserve water because your body's always fighting this battle. When you're dehydrated, you release a lot of this to hold on to water because you don't want to lose any of it. All right. The second fact you had to know was that alcohol blocks ADH. Okay, so if you remember, we are talking about a hormone, hormone that helps hold on to water. But if you block that, the end result is, without ADH, the end result is you are going to pee more. Okay, so alcohol will block the ADH, block the main mechanism of holding on to water in your body, so therefore you pee out more water and you lose water from your body. For number 6, what we're talking about is now the temperature's gotten cold. So you've got this guy walking through the desert, the temperature gets cold, and all of a sudden his body has to try and conserve heat now versus letting go of it. Right? So you really should go and review the thermoregulation video if that's not already clear for you guys. But the main two things he's going to do is he's going to vasoconstrict, which means he's going to close the blood vessels in the skin. That's going to hold on to the heat. And then he's also going to start shivering. And the shivering, as we mentioned, is going to require ATP. So shivering needs ATP. And if you have enough ATP, if you use the ATP up, you have to make more. And the only way we make more in big quantities in the body is cell respiration, which also gives us heat. Okay? So the heat that comes from cell respiration is the real big benefit. I know that's really short, but go back and see the thermoregulation video for more help on number 6. So for number 7, it's asking you what will his complexion look like. And we're in the opposite scenario. So before, his complexion was red because he had vasodilated and he was letting out all that heat. Now he's vasoconstricted, which means the blood vessels are closed, less blood is flowing to the skin, so he would look very pale. Okay, so that's what we're really talking about. I'm trying to remind you of that difference. You notice that when people are cold, their face tends to be very pale. It's more obvious the lighter complexion somebody is, but your skin tends to become very pale, and around your lips and things like that becomes very, very pale when you're cold because of the vasoconstriction. All right, so for number 8, we got to go back. I want to make sure everybody understands what they're talking about here. So we're saying that for the first time, he's starting to feel better. He's able to think clearly. He doesn't have the dizziness or the confusion. So cognitively, he's feeling better. Remember, all of that was caused, if we go back, all of that was caused because he had this low blood pressure, right? The low blood pressure, okay, is what caused it. The low blood pressure because he was sweating, because of the vasodilation, and he then wasn't getting enough blood flowing up to the brain, right? But what has changed now in number 8? Well, he is no longer sweating, so he's not losing any more blood from the body or heat from the body. But the more important thing is the fact that he is now vasoconstricted. So with the vasoconstriction, that means he's closed down the blood vessels within his skin. He's closed down the blood vessels within his skin, and he is now letting out less heat of the body. That's why he's really doing it. But the nice side benefit is that he's now brought blood pressure back up. Imagine the blood vessels are shrinking in diameter. They're going to squeeze the blood more, and you're going to increase blood pressure. So vasoconstriction increases your blood pressure, which means more blood is now going up to the brain. So our problem from back here is solved. We're now going to have plenty of blood now flowing back up to the brain because you're going to have a higher pressure. Okay, so last one that I'm going to put on here, guys, is number 9. So number 9 asks about, all right, well, he peed into a bottle, he tried to drink his own urine, and he couldn't stomach it, and why is that a good thing for him? Well, the biggest thing you want to remember, guys, is he's not fresh out there. So it's not like he's just peeing into a bottle and thinking about drinking it. Like Bear Grylls talks about all the time that you can drink your own urine. It's a really good idea. At this point, Mike is going to be really, really dehydrated, which means his urine is going to be very, very concentrated. It's going to be a severely hypertonic solution. So let's remember what... So if it is hypertonic, that means the cells of his body, remember the cells of his body are going to be, someplace 98, 99% water. The urine is a much lower percentage. Let's say it's only 90% water. This is just like what we talked about that unit about drinking salt water. Okay. At this point, what will happen if he drinks this in, the water will leave his cells. It'll actually leave his cells. He'll actually cause further dehydration. So as the water leaves his cells, his body then has more water that it can pee out. Okay, when a person is already dehydrated, their urine is going to be so strong and so concentrated that it'll actually cause further dehydration that way. Plus, your urine contains all the toxins, guys. Urine is made to get rid of poisons from the body. The most common one is called urea. And that's what makes your urine yellow and smell the way it is. And urea is toxic to the body. Now, short term, probably not going to kill him, but you're taking all of this stuff that his body's been trying to flush out and putting it right back into the body, so it would also make him sick. It would probably lead to more fatigue, would not help him in any way. So hopefully this helps, guys. And in class, we'll go over the next few questions.